Hey everyone, so this is our next section in chapter 4 that we are going to be talking about. We are now in section 4.3 and we are learning the last method of how to solve systems of linear equations. This last method is by elimination. If you remember, we first learned solve by graphing, where we graph and look at the intersection point. Then we talked about solve by substitution, where we substitute one equation in for a variable in the other equation. And now we are talking about this last method, elimination. And this one can be tricky, so make sure you take good notes, follow along, use these steps. So what is the elimination method? It's a method of solving a system by adding or subtracting the equations, guys. It's crazy. We're going to be adding or subtracting two equations together in order to eliminate one of the variables. Note, it is best to use this method when the coefficients of x and y are both greater than 1. So it's like, when do you use which method, right? So if you've got coefficients of 1, you should probably use substitution. If they're greater than 1, elimination is going to be your method. Okay, so here are our steps. The first step, decide which variable to eliminate. And we'll talk about how you're going to do that. Step number 2 is multiply one or both equations by a constant so that adding or subtracting the equations will eliminate the variable. And then we get to add or subtract the equations to eliminate one variable and then solve for the other variable. Next, we'll go back to substituting. We'll substitute the value into either original equation to find the value of the second variable. And then we will be able to write the solution as an ordered pair. We are still doing that. Okay? So let's check out some examples. We've got lots to do together. Our first one, let's look at problem 1. So these are easy because we have a variable that has a coefficient of 1. So see how it's just 1x and 1x, okay? So, and also we've got 3y and negative 3y together. When we have variables that have the same coefficient, that's what is easiest for us to eliminate, okay? So if you guys look at here, we have x and x. Well, if we subtract, if I do x minus x, this variable will eliminate, and that's what we're going to do. I'm going to subtract these two equations, and we subtract like terms, okay? So I'm going to do x minus x. Guess what? That gives me 0. That whole variable just got eliminated, and that's the name elimination. And then I'm going to do 3y minus negative 3y. Guys, watch your signs. 3y minus negative 3y. That becomes 6y equals negative 2 minus 14 gives me negative 16. Okay, and then we're going to divide both sides by 6. And I get y equals, and I'll reduce this, negative 8 over 3. And that's part of my answer. And then the next step is we have to substitute that back into either equation, it doesn't matter which one, and solve for x. So I'm just going to take the second one, and I'm going to do x minus 3, substitute in what I know y is. These 3's are going to cancel, and I'll be left with x plus 8 equals 14. Subtract the 8, and we get x equals 6. So then I could write my answer as 6 comma negative 8/3. Weird one with the fraction, but that's okay. Let's check out B. So if we look at B, we need to figure out which variable has the same coefficient. Look at our y's this time. They both have a coefficient of 1. And I need to figure out if I'm going to add these equations together or subtract these equations. And what we need to do is pick the one that would eliminate these y's. And so if you're stuck, look at the coefficients. They're both, it's a -1 and a 1. So think about it. If I do -1 plus 1 or a -1 minus 1, which one is going to give me 0? Well, this one gives me -2, this one gives me 0. So I need to add these two equations together. 2x plus 4x gives me 6x. -y plus y gives me 0. It's eliminated. Equals 9 plus 21. That gives me 30. And then I'm going to solve this for x. X equals 5. Halfway there. And then I'm going to take that, pick either one of these equations. I'm just going to pick the top one. 2 times 5 minus y equals 9. 10 minus y equals 9. If I subtract the 10 on both sides, I'm going to get -y equals -1. Divide by -1 on both sides, y equals 1. Put my answer together. 5, 1 is my answer. Let's check out C here. Which one do we want to eliminate? The 2x's or the y and the 2y? Well, they've got the same coefficient. That's the one we want to eliminate. So think about that. If I do 2 plus 2 or 2 minus 2, which one's going to get me to eliminate is if I subtract. That's how we figure that out. And then I'm going to subtract these two equations, the common terms. 2x minus 2x, amazing, they eliminate. Y minus 2y gives me -y, equals 10 minus 12 gives me -2. Divide by -1, y equals 2. And then I'm just going to grab an equation, substitute that in, solve for the other variable. And so my answer is 4, 2. Okay, and then you guys can try D on your own. I'm going to move on. So these are more similar problems. This time, though, notice we don't have coefficients that are the same. So if you look at 2a, none of my coefficients are the same. Okay, so I want to think about, okay, if I multiply one of these coefficients by something, how could I get it to look like either of the other coefficients? So if I look at the 5 and 4, could I multiply the 5 to get 4 or the 4 to get 5? I can't, right? But if you look at this 2, well, hey, I can multiply that 2 by a 3, and then we would get the same coefficients. So let's do that. And what we're going to do is we're actually going to multiply it by a -3 to help us later on. Okay, so if we do that, my systems of equations, that first equation stays the same. But then I'm going to multiply that -3 to everything in this second equation. So I'm going to have a positive 6x plus 12y equals -42. And now we're back to problems like before. Now we're back to, oh, I've got the same coefficient, so how can I get rid of that variable? And so I've got -6 and 6. If I add or if I subtract these, will I get 0? Well, if I add, that's what I wanted. -6x plus 6x gives me 0. That eliminates the variable. 5y plus 12y gives me 17y. Equals 25 plus a -42 gives me -17. Divide by 17, y equals -1. It doesn't matter which equation we use. I'm just going to grab the first one to solve for x. So I'm going to have -6x plus 5 times -1 equals 25. -6x minus 5 equals 25. Add that 5 over, and I get x equals -5. -5, -1 is my answer. Okay, let me show you that one more time. Look at here. I've got 3x and a 6x and a 1 and a 3. So if I multiply, it doesn't matter which one. You could do the x's or you could do the y's. Because we eliminated the x's here, I'm going to eliminate the y's in this one. It doesn't matter, we'll get the same thing. I'm going to choose to multiply that top equation by a -3, right? Because then this y is going to become matching coefficients. So let's distribute this -3 to everything. And I'm going to get -9x minus 3y equals -33. Second equation stays the same. And again, figure out, in order to get rid of those y's, do I need to add them or subtract them? And we need to add them. -9x plus 6x gives me -3x. -3y plus 3y eliminates. And -33 plus 33 gives me 0. I'll divide by -3, x equals 0. Grab one of these equations to solve for y. Substituting x in for 0, 0 in for x, this is 0, 3y equals 33, y equals 11. 0, 11 is my answer. And then one last, you guys can try these on your own. One last thing I want to show you guys is problem 3. These are the biggest troubles because we need to multiply both the top equation and the bottom equation by something. What I mean by that is look at the -2 and the 5. Neither of those, if I multiply the 2 by something, won't give me 5, and the 5 by something won't give me 2. Same thing with the 3 and the 8. They're not multiples. So I need to multiply both the top and the bottom. So let's multiply this top equation by 5. This will make it a -10, and this equation by 2, hey, that'll give me a -10, a positive 10x. Okay, and that's what I want. Distribute that 5 to everything. Will give me -10x plus 15y equals 35. Distribute the 2 to everything. It'll give me a 10x plus 16y equals -4. Now we've got the same coefficients, so I know we can add. Eliminates my x's, and I'll be getting 31y equals 31. Divide by 31, y equals 1. Grab either original equation, I'm going to grab that top one, and -2x plus 3y, substitute in the 1. -2x plus 3 equals 7. -2x, subtract the 3 gives me 4. X equals -2. Okay, and I'll set up this last one here. Again, the 5 and the 3 aren't multiples, the 4 and the 3 aren't multiples. So again, let's work with those x's. So if I multiply this top equation by 3 and the bottom equation by 5, I should get common coefficients there for my x's. Distribute the 3, I'll get 15x minus 12y equals 24. Distribute the 5, hey, -15x, perfect, plus 15y equals -15. Now I see my system of equations. If I add them, 15x plus -15x, it eliminates. That's just what I want. -12y plus 15y gives me 3y. 24 minus 15 gives me 9. Divide by 3, y equals 3. Pick either one. I'll just pick that top one. 5 times x minus 4, substitute in the 3. 5x minus 12 equals 8. Add the 12 over. X equals 4. So my answer is 4, 3. Okay, we have to get the hang of this elimination process, but I know you guys can do it. Great job, guys. You can just fill in the ones we did. You can leave the other ones blank. That's all good. Great job, guys. This was the start of 4.3, Solving Systems of Linear Equations by Elimination.